In section 2 of chapter 7, we're going to take a look at polynomials. We'll define a polynomial and learn how to classify polynomials, and then later evaluate polynomials for a given value of a variable. And again, we've done some of this before, so a little review as we focus first on vocabulary. What is a monomial? Well, the general form for a monomial is something that looks like this, where x is your variable, n is the exponent, and k is the constant or the numerical part. Now, the number of the exponent on the variable is referred to as the degree of the term. Only on the variable, not on the k. And the formal name for the k is the coefficient. And we've used this before. Now, what makes something a polynomial? Well, that it has more than one term. And how are the terms separated? They're separated as a sum, that is a plus sign, or a difference, a negative sign, between the terms. Now, we talked about the degree of a term. What would be the degree of the polynomial? Well, you figure out the degree of each term, and then which one is the highest. That's the degree of the polynomial. And we'll see some examples of this as we go on. And then another vocabulary word, leading coefficient. Once you put the highest degree on the left, that is, have them the highest degree on the left, then whatever the coefficient of that highest degree term, then that is called the leading coefficient. And we'll see examples of this too. So a monomial, polynomials with one term, these are examples. A binomial, polynomials with two terms. Again, we're using the prefix mono for one, bi for two, tri for three. And you might say, well, on this trinomial, and its highest power or degree is 2, so the leading coefficient here, when there isn't one listed, is a 1, as it is for this one as well. Now, these are just special designations we give for these first three. Otherwise, 4 or more terms, as well as these, are referred to as polynomials. Now, when we simplify polynomials, it's really just combining like terms. We did that in an earlier lesson. So when we do that, if the variable part is the same, we only work with the numerical coefficient. So 5 plus 7, 12. 12x to the third. Now again, we have two like terms, but this one isn't, so we just work with combining like terms. And the other term is this. Now, once they're in this form, our leading coefficient here would be a 12. The degree of this term would be 3. Degree of this term is 1. And the degree of this expression now is 3. The highest single term. Alright, now we have worked somewhat with fractions, so I want to spend a little more time here working this with you. So our like terms are these two, and we want to combine. Now, remember this 3 is over 1, so in a sense, if we combine those two here, and we factor out the fraction and the whole number here, we get 1/2 plus 3 over 1. And we need to combine these terms. Now, in order to add fractions, we must have the same denominator. So our common denominator here would be 2. So we have to do something to this whole number to make it a denominator of 2. So we're allowed to multiply it by 1, but now in the form of 2 over 2, which now changes this to 1/2 plus 6/2. So we add these together now. The denominators are the same, so 1 plus 6 is 7/2 y. And to put this in sequential order, we're going to go a negative 2/3 y squared. That was this term. And then this term we said was a plus. So now we have to show the plus. And then minus 7. So our leading coefficient would be this. The degree of this expression now is 2. All right, let's see what they do. And again, they're not showing us how they got there, but we did. Okay, so here, as we look at this, and we could rearrange these, put them together, or we could do it mentally. This is a 1x squared minus 1x squared. This just becomes a 0. So the remaining expression simplified is just 8x minus 15. Now, as you look at this, are there any like terms? No. But notice this one has a negative exponent. And they are now giving us a definition of whether something is a polynomial, classified as that, or not. And the protocol for that is you can't have a variable with a negative exponent. That is not considered a polynomial. Now also, if we had it written this way, if we take this negative exponent, as we had in an earlier lesson, and brought it to the denominator, it's now a positive exponent. This also is a note that makes this not a polynomial. So if a variable has negative exponents, or if a variable is in the denominator, as we see what would happen when we brought this to make it positive, these are not a polynomial. Now here they're asking us to evaluate given x being a value of 3. So we just stick the 3 in carefully through substitution using parentheses, as they show here. I like this method. So 3 squared is 9. 4 times 9 is 36, plus 15, minus 15. So these two are just going to cancel each other out. So you're left with 36. So something rather easy. Again, the technique of putting that variable in parentheses so you can evaluate it properly. Now here we're going to stick in a negative 2 in each of these cases. Now notice a negative 2 cubed is going to give you a negative 8. Times 5 is negative 40. But squaring a negative 2 gives you a positive 4. And then here, this is a negative times a negative, gives you a positive 6. And then just adding everything up, you end up with a negative 22. Now, here's another type of thing you're going to run into where they're saying the value of x is actually a binomial in a sense, 2a plus 1. So wherever the x is, you put in 2a plus 1 in a parentheses, like so, multiply through, clear parentheses, group like terms, and there's your answer. Now, we've been working on a lot of different things, and some of the items were long, so I'm going to keep this short. Here are the few more examples, if you like, and then there are the answers.